Many people believe that if a desert heats up to 50 degrees Celsius during the day, it must stay warm at night as well. But this is where most people are mistaken. As soon as the sun disappears behind the horizon, the temperature can plummet by nearly 50 degrees Celsius in just a few hours. In the evening, you can get heat stroke, and by morning you could freeze. How does the same place transform from a scorching frying pan into a real freezer in just one night? In this video, we'll figure out why sand hardly holds heat, where tens of degrees vanish overnight, and why nights in some deserts are colder than winters in many cities. Once you learn how this happens, you'll never look at a desert the same way again. During the day, the desert sand warms up to 80 degrees Celsius. You could boil an egg on it in 15 minutes or ferry an egg directly on a flat stone. It seems like such a massive amount of scorching earth should take days to cool down. In everyday life, we are used to something else. If you heat a large brick on a campfire, it stays on the ground burning your fingers until morning. Many think the same thing happens in the desert. The logic seems simple. Since there's so much sand around, it should act like a giant radiator, keeping everything warm all night long. But in nature, everything works in the exact opposite way. The main reason lies in the sand itself. It consists of small quartz grains. This material has one important characteristic. It absorbs heat instantly and loses it just as instantly. Sand grains cannot hold energy inside themselves for long. Furthermore, the sun warms only the topmost layer of the desert. If you scoop away the sand with your hand just 15 centimeters deep during the intense midday heat, about the length of a standard ballpoint pen, the ground underneath will be cool. Sunlight simply cannot penetrate deeper. All that intense heat accumulates in a thin crust no thicker than an index finger. Underneath this thin crust lie millions of tons of cold earth that haven't seen the sun at all. Moreover, between the grains of sand are countless microscopic air pockets. Air itself is an excellent thermal insulator. Instead of transferring daytime energy deeper and deeper into the ground, dry sand traps it right at the surface. This creates a paradox. During the day, the sandy cover works as an ideal shielding barrier that simply doesn't let heat pass downward. As a result, the lower soil layers remain as if in a cold cellar. Once the energy source disappears, this paper-thin scorching layer cannot draw heat from the depths because those depths are cold. The sand simply has nowhere to draw new energy from to maintain its temperature. As twilight arrives and the sun sinks below the horizon, this thin hot crust gives off all its heat to the air in literally half an hour. The sand cools instantly. If you stand barefoot on a dune 2 hours after sunset, the ground under your feet will feel like an icy crust. The sandy ocean completely stops warming the surrounding space. At the same time, there is no water in the sand. In a typical forest or meadow, the ground is always damp. Water cools very slowly and maintains a stable temperature until dawn. In the desert, however, there is no moisture at all. Dry sand radiates energy many times faster than garden soil. However, besides the cooled ground, the air heated during the day remains, and it vanishes just as quickly, but for an entirely different reason. Behind this process is another invisible factor that most people don't even suspect. During the day, the earth is heated by the sun, and at night it begins radiating this heat upward. But water vapor traps hot rays and prevents them from rising high. On top of that, clouds cover the sky like a lid on a pot. As a result, heat stays near the ground, which is why night temperatures in temperate latitudes drop by only 5 or 10 degrees Celsius. In the desert, this protective blanket is completely absent. Air humidity here often drops below 10%. For comparison, humidity in an ordinary apartment during winter is around 30%. There are no water droplets in desert air, and there are almost never clouds in the sky. Because of this, the following process occurs at night. As soon as the sun goes down, the scorching earth starts radiating all the heat accumulated during the day upward. But there are absolutely no obstacles in its path, no clouds, no water vapor. Heat doesn't linger near the earth for a second. It shoots directly into open space at the speed of light. The earth radiates its energy into the empty sky, just like an open stove gives all its heat away to the outside if it has no walls. In physics, this process is called radiative cooling. Any heated object constantly emits infrared waves. In the humid climate we are used to, These waves constantly collide with water molecules in the air and reflect back to the ground, creating the greenhouse effect. In the desert, infrared rays face no obstacles whatsoever. The atmosphere above the sand becomes completely transparent to radiation, and all daytime energy escapes continuously straight into outer space. In ancient times, nomads noticed this process. They used to say that at night, the clear sky sucks away all the living heat of the earth. In a way, they were right. A hole forms in the atmosphere above the desert, through which all the daytime heat escapes beyond our planet. This process continues nonstop until morning. If you place an ordinary metal sheet or a flat stone on the sand at night, it will cool down even faster than the surrounding air. The metal gives off its heat and becomes a few degrees colder than its environment. That is why, right before dawn, dry frost sometimes forms on dry stones and metal objects in the middle of the desert, even though there isn't a single puddle around. The air yields its last remaining energy, and a noticeable cold emanates from the ground. If you stand on a dune at that moment and look up, it becomes clear. The absence of ordinary water vapor has turned this place into an open window into endless space. Nighttime cold is not distributed evenly across the desert. When the sun disappears, the air above the top of the dunes cools down first. By the laws of physics, cold air becomes heavy and rapidly flows down the sandy slopes. All this cold mass collects in the hollows and basins between the sand hills. As a result, natural freezers form between the dunes. If the temperature at the top of a sandhill is high as a 9-story building stays around plus 5 degrees Celsius at night, down at its base, the thermometer can easily drop to minus 3 degrees Celsius. Moving just a few steps down the slope can mean a temperature difference of 5 to 7 degrees Celsius. Falling into these basins, a person finds themselves in a natural trap. In the history of desert warfare in North Africa, soldiers suffered massively not only from the daytime heat, but also from nighttime frosts. Tank and armored vehicle crews faced a simple problem. During the day, the metal armor heated up so much that you couldn't touch it with a bare hand. But by 4 a.m., the tank cooled down to the state of a metal box from a freezer. Soldiers tried to sleep inside, but the metal quickly drained all the remaining heat from the human body, causing many servicemen to suffer severe hypothermia right inside their armored vehicles. Such sharp temperature swings have a destructive effect on the entire environment. Rocks and boulders in the desert expand during the day under 50-degree heat and contract at night from the sharp cold. The surface of a rock cannot withstand such constant tugging. In the pre-dawn hours, loud popping sounds often echo across the desert. These are solid boulders the size of a passenger car cracking and shattering into pieces. The sudden nighttime temperature shift literally tears rocks apart from the inside in a matter of seconds. Even water behaves strangely here. If you leave an open plastic bottle of water on the sand overnight, by 5 a.m. the liquid inside can completely freeze. A thin crust of ice appears on the surface of the dunes. Yet there isn't a single cloud in the sky, and the usual humidity is absent from the air. This thin layer of ice forms from the rare trace amounts of vapor present in the air due to the instant cooling of metal objects and stones. A human without special equipment endures such swings with great difficulty. The body spends immense resources trying to adapt. During the day, the body sweats profusely to cool down and avoid overheating. At night, that same body begins to shiver continuously to generate internal heat and warm vital organs. In a single 24-hour period, a person experiences two opposite seasons. Sudden nighttime frost regularly became a fatal trap for inexperienced travelers. The main mistake beginners make in the desert is taking only light summer clothing to escape the daytime heat. But when the temperature drops to zero, thin fabric stops offering protection. Sweat-soaked clothing is even more dangerous. During the day, a person sweats heavily, and at night the damp fabric acts like a cooling chamber, accelerating heat loss several times over. Desert nomads, Bedouins, and Tuaregs developed their own protection system centuries ago. Their famous loose robes made of thick wool serve not only to protect against the sun. At night, this same layered clothing retains a layer of warm air near the body, preventing the icy wind from stealing remaining heat. Furthermore, experienced guides never slept directly on the sand. They built raised beds out of branches or clothing, creating an air barrier between their bodies and the rapidly cooling ground. Without this knowledge, surviving in the night desert turned into a harsh ordeal of extreme cold. But while humans can wear thick wool clothing or build a fire, desert inhabitants have neither sleeping bags nor warm robes. How does wildlife cope with these challenges? How do small animals and insects survive this continuous struggle between heat and cold? Under these conditions, all living creatures must adapt. Over thousands of years, desert animals have learned to use the properties of the earth to escape both heat and cold. Small rodents, jerboas, and fennec foxes dig burrows at a depth of about 20 centimeters. During the day, they stay underground waiting for the heat to subside, and at night they come to the surface. Their bodies are adapted to the sharp drop in temperature. The fennec fox has thick, dense fur, even on the pads of its paws. This fur prevents its paws from getting frostbitten while walking on frozen sand in the pre-dawn hours. In addition, thick fur traps internal body heat at night, preventing the animal from freezing at 0-degree temperatures. Cold-blooded animals use a different tactic. Snakes and lizards cannot regulate their own body temperature. If a snake remains on the surface at 4 a.m., its blood will cool, its muscles will stop contracting, and it won't be able to move. Therefore, as twilight falls, lizards and vipers burrow into the sand to a depth of 15 centimeters. At this depth, the earth retains remnants of daytime heat until morning. The sand acts like a heating pad for them. Insects have also adapted to nighttime conditions. Desert darkling beetles use the night cold to harvest water. When the air cools before dawn, the beetle climbs to the top of a sand dune. It raises its rear body upward and faces the pre-dawn wind. Its shell cools faster than the surrounding air. Moisture from the cool air begins to settle on the beetle's smooth shell in small droplets, which then roll down its back straight into its mouth. In this way, the insect gets water in an absolutely dry place. Large mammals like camels adjust their bodily functions depending on the time of day. During the day, a camel allows its body temperature to rise to 41 degrees Celsius to avoid wasting water on sweating. At night, its body intentionally drops its temperature down to 34 degrees Celsius. This allows it to store cold inside itself for the next hot day. The camel's back hair is about 10 centimeters thick. During the day, it blocks solar heat from reaching the skin, and at night it prevents internal heat from escaping. Animals prove that surviving in the desert requires precise resource calculation. Humans also noticed these natural processes and learned to turn nighttime cold to their advantage through simple engineering solutions. People learned to harvest real ice in the middle of scorching lands long before the invention of electric refrigerators. In ancient Persia, builders erected special structures for this purpose called Yakhchals. Externally, a Yakhchal resembled a giant clay cone as tall as a 4-story building, with walls up to 2 meters thick at the base. Builders mixed mortar made of clay, sand, animal hair, and lime. This mixture was completely waterproof and barely heated up in the sun. Inside the Yakhchal was a dome-shaped subterranean chamber as large as a spacious 2-story cottage. Next to the structure, workers dug a long, shallow canal and filled it with water from underground springs. Tall walls along the canal shielded the water from direct southern sunlight, keeping it cool during the day. At night, desert physics kicked in. As soon as the air temperature dropped toward zero, the water in the open canal began radiating all its heat into the clear sky. In a few hours, a layer of ice as thick as a palm formed on its surface. Before sunrise, workers chopped this ice with crowbars, carried the blocks inside the Yakhchal, and stacked them in the underground chamber. Natural ventilation worked inside the storage unit. Builders left holes at the very top of the cone, while cool night air entered through lower pipes. Warm air rose and escaped through the opening in the dome. Thanks to thick walls and subterranean depth, the temperature inside the Yakhchal remained below freezing year-round. In the heat of summer, when it was plus 40 degrees Celsius outside, people retrieved solid ice from the clay cone to preserve food. In North Africa, nomads used an even simpler method. They poured water into porous clay jars and left them on high ground overnight. The clay absorbed moisture, and microscopic droplets seeped onto the outer wall of the vessel. Night wind instantly evaporated this water, stealing heat from the jar itself. By morning, the water inside the clay vessel cooled almost to freezing. These ancient structures prove that desert night cold is not an accident, but a constant natural resource. Humans learned to turn climate extremes to their advantage. But what would happen if this familiar mechanism of daily temperature swings suddenly failed? What would happen to the desert if the air above the sand became humid for just a single day? If high humidity appeared in the desert for even one day, the familiar mechanism of nighttime cold would instantly break down. Clouds and water vapor would act like a giant lid trapping heat near the ground, and night frost would stop. The desert would temporarily turn into a muggy steam room, with nighttime temperatures around plus 30 degrees Celsius. Without sharp temperature fluctuations, rocks would stop cracking and fracturing, and beetles and lizards would lose their primary source of moisture, pre-dawn condensation. Changing just a single parameter, humidity level, would completely rewrite the physics of this ecosystem and destroy a unique survival chain formed over millennia. But as long as the air above the sands remains dry, this natural process repeats every single day with absolute precision. A daily temperature swing of 50 degrees Celsius comes from the interaction of three main physical laws. Properties of sand. Dry quartz grains heat up instantly at the surface but cannot conduct or store heat deep down. As soon as the sun leaves, this paper-thin upper layer gives off its remaining energy to the air in just half an hour and becomes ice cold. Lack of a water shield. In temperate climates, humidity and clouds work like a warm blanket. In the desert, humidity approaches zero, so infrared radiation from the cooling earth shoots straight into open space without encountering any barriers. Terrain and air physics. Cooled, heavy air flows down dunes into hollows, creating localized natural freezers. In pre-dawn hours, sudden thermal contraction fractures and tears apart even the hardest rock formations from the inside. Living organisms and humans have learned to turn these harsh laws to their advantage. Animals escape the night frost deep in the soil, which retains steady warmth. And humans, since ancient times, have used the properties of dry air and evaporative cooling to freeze water in the middle of burning sands. The desert only appears to be a place of eternal heat at first glance. In reality, it is a complex system with the starkest contrasts on the planet. By day, this dry land takes the full force of the sun. But as soon as twilight falls, it freely gives away all its accumulated heat to the icy cosmos, strictly on schedule every single day. The next time you look at a photograph of sand dunes, you will know exactly what physical laws are hidden behind that picture-perfect scene.